Hello, my name is Faye, and welcome to the unofficial Makera community channel. This YouTube channel will post updates to the machine firmware, controller, and post processors we have been developing, and occasionally post tutorials. If you want to follow our progress, we have a GitHub and Trello for feature and issue tracking, and you can subscribe to this YouTube channel. Links are in the video description. This video is a breakdown of the updates to the Fusion post processor, including manual tool changes, manual NC commands, fixes to the fourth axis, machine simulation, and a few other minor bug fixes. To install the Fusion post processor and machine files, go to the GitHub page linked in the video description, go to the Releases tab, scroll down and download the .zip file, unzip the file, and open Fusion. One of the better ways to do that is to open this Carvera Fusion preset manufacturing, because that is what we will be using in this video to show off the features. Once inside of Fusion, open the manufacturing tab and select the machine library, and go to the local or cloud tab. Once inside of here, you're going to want to delete any existing Carvera machine profiles and import. Select from my computer, go to the folder that you downloaded into, and import the 3 and 4th axis variants. As a real quick sanity check, you're going to want to edit each of your machine files. Click into post-processing, make sure that it says Makera-Community post with the latest number here, and go into the model and see Makera Carvera 3-axis community version. If those are both good, you're good to move on. If not, leave a comment and I will help you work through the process. Now in the Manufacture tab of the Carvera Fusion preset manufacturing file that we opened earlier, if you select either of the toolpaths with the little eyeball next to it, it will step between two different G-code setups. And as you can see, the machine file is set up and visible. If the machine file is not visible or you want to hide it, hold Control or Command and hit M, and that will toggle on and off the machine file. Otherwise, at the very bottom of the screen, there's a set visibility where you're able to turn on and off the machine and set it as transparent. If you want to simulate manufacturing a file with the machine, if you right-click your setup, Simulate with Machine, and you can hit play. One thing to note while doing machine simulations is that in the View Viewport tab, you can set which part of the machine is moving. So right now I have this set to machine base, and you can see the part is moving. But if I were to set this to model, then the whole machine is moving around the part. To set up machine simulation, if you right-click and edit your setup, make sure that your stock point is set. In this case, I am probing the bed, so my stock point is at the bottom of my part. If I were probing the top of my part, I would put my origin at the top of my stock. Otherwise, if I didn't want this exact orientation, I could switch from model orientation to choosing axes, where I could choose an X and a Y axis. And you can see my next X is now up and my Y is now left. I'm going to cancel out of that and reopen this setup because I liked where my origin was. And then for the machine simulation, I have my machine set to the right value, and I go to the part position tab. I can choose a part attach point. In this case, I'm going to select a stock point, which is going to be this corner, and my table attach point, which will be the corner of anchor 1. And then I can clear my offsets that I had set up. And now my part is located at anchor 1. And next time I simulate, this will be set up. The custom G-codes file shows setup for a 4th axis. If I edit it in setup, I want to make sure that my x-axis moves along the rotation of the a-axis. My y-axis goes to the back and my z-axis goes up. And my origin is set to the center of my part. Now if I go to the part position tab, for this one I selected my first attachment point as that same center position of my work coordinate offset. And in my table attach point, I selected this circle here, which is the center of the rotation axis. From there, I offset it a little bit along the x-axis in order to move it away from the chuck, just like I would on the actual machine. When you are setting up to run the file in the Carvera controller, be sure to set the x-axis offset appropriately as the distance between the probe location, which is back here, and the place you want the WCS origin to be, which is here. Moving on to manual NC commands. The first setup in this file goes through the various custom G-codes implemented by this post processor. You can see all of the commands implemented when selecting the post processor in its long description on the right-hand side here. To view or edit a manual NC command, you can either double-click it and it will open up this window, or right-click Edit, same thing, it'll open up this window. They will all have a drop-down field to choose which type of manual command that you're going to run, and potentially have a secondary import field. In this case, this manual NC generates a comment that says Start of Manual G-code, and puts the parentheses around it so that the comment is formatted correctly. Do note that not all of the drop-down menu options are implemented, as the Carvera does not support those features. For instance, the Carvera has no method of closing or opening the door, and it does not have any form of chip transport. Any of these manual NC commands can be copied or pasted between files, but if you want to start from scratch, you can add a new manual NC command under Setup, Manual NC. The first major set of commands in this setup are all what are called action commands. So you set the manual type to action and then type in a value. Note that all of the action commands are case sensitive. Stepping through them quickly, rapid A, colon, and then a value in degrees will move the A axis to 90 degrees. Safer A, colon, 365 will move the Z axis out of the way first and then rotate the A axis to 365 degrees. Safe Z will move only the Z axis to its home position. Shrink A resets the A axis to a value between 0 and 360. So if the A axis is at 400 degrees, this command will reset it back to the equivalent of 40 degrees without moving the axis. Spindle off shuts off the spindle. Clearance goes to the clearance position with a G28 command. Clear auto level will remove any grid leveling that has been applied to the machine. Feed override, colon, percentage value, in this case 80, will set the feed percentage to 80%. Reset feed override will set it back to 100%. Air on and air off will turn on and off the compressed air respectively. Autovac off and autovac on will turn on and off the auto vacuum feature respectively. Similarly, vac on and vac off will turn on and off the vacuum. Light on and light off will turn on and off the light. The next set of commands are built-in commands that do not use the action setup. If you set the manual type to stop, this will add an M600 pause that waits for user input to hit the play button. Dwell will pause for a dwelling period, in this case 4 seconds. Measure tool will perform an automatic tool length calibration on the current tool. And the last of the manual commands are all implemented only with the community firmware. There's a link for that in the description. Tool break control will test the current tool for breakage and alarm if broken. There's a different way to do this per tool that I will explain later in the video. Optional stop will add an M1 command to the G-code, which will pause the file when optional stop mode is enabled. Setting the manual type to pass-through and then typing in M333 will turn optional stop mode off. Pass-through of M334 will turn on optional stop mode. M335 will turn off single block mode. And M336 will turn on single block mode. In single block mode, the machine will pause after every valid line of G-code and wait for the user to hit play. Open macro by number will open macros/2003.cnc with this command, M98P2003. Open macro by path, M98.1. You put the path in parentheses, so you have macro2.cnc. You could also do a folder, test/macro2.cnc, for a G-code in a subfolder. And if you want to run any other arbitrary G-code using a manual NC command, you use pass-through and add whatever the command you want to use inside of the message box. You can see the output of these commands by post-processing the custom G-code setup to see what each of the particular commands does. Next up are changes to how manual tool changes work. If you look in the second setup, you can see that there are a few different tool paths included, one of which is labeled as tool 12. If I go into the post-process setup, one real quick note is I like disabling create NC program because it just clutters the outliner. And from here, if you make sure that the machine is set to the community machine, post is set to the community post, on the right-hand side, you'll see some options in the properties panel. The first dropdown dictates which method you want to use for manual tool changes. For the full-size Carvera with the community firmware, the community option will allow any tool number greater than 6 and less than 99, and allows you to determine if you want to automatically set tool length offset. In that section, I will show you how to set up to use a known tool length offset or manually calibrate the tool length offset without the tool setter. If you're using the stock firmware and still want manual tool changes, the Fusion manual tool changes setting will add in tool change. When the tool shank size changes, the tool is marked for manual tool change, or the number of the tool is greater than 6. The community firmware version is much improved. The Carvera Air method passes through the tool number to the machine without any edits. This will error out on the full-size Carvera for tools greater than 6. And finally, the error on more than 6 tools will fail to post-process if you use a tool number greater than 6. This is the default behavior of the stock post-processor. I'm going to set mine to Carvera-Community tool changes. The other two changes inside of the post properties are community bug reports. The first of which is if you are using split by toolpath, you can write tool number and the header to each split by toolpath file. That allows you to run any of the split toolpaths individually without having to run the previous ones first. In the bottom section of the post settings, I changed the default value of high feed rate to 140 inches per minute or 3000 millimeters per minute. Fusion has been a bit weird about this value, so it might default to 140 millimeters. This value is used when the high feed rate mapping is set to something other than preserve rapid movement and replaces G0 commands with G1 commands with this particular feed rate. If this high feed rate is set to 0, it will cause an error on the Carvera, and this minor change is avoided. Last up to the changes in the post processor show up when you edit tools. In the post section of the tool, if you have the community firmware, the brake control tick box will run a tool brake test when switching to the next tool. And if you are using either the Fusion or Community manual tool change settings in the post processor, the manual tool change tick box will force a manual tool change. The tool comment section is used by the Community firmware manual tool changes to determine how to manage tool length offset. If it is blank or contains TL0:A, the machine will perform an automatic calibration. If it contains TLO:M, the machine will not perform a tool length calibration and will remain paused so that you can set the tool length offset with M493.3 as shown in the firmware video. If the comment contains TLO: followed by a number, the firmware will set the tool length offset to that number and continue the program. That's it for this update. Next up for the post-processor files are some updates to the tool library for the various thread mills and models for the collet shank holders to improve the simulation. Thank you for watching.